or if we do a bidon plate on an aluminum plate, right? Thank you, Eddie. Thank you for the answer. That's, again, you guys have much more knowledge when it comes to these kind of things. So thank you for sharing with the group all this stuff. And this is actually something really interesting, and we know from but Dr. Mendez' class last week that we know that TIG runs on constant current, and usually we have it on electronegative. But there is some advantages on changing the polarity. Of course, we're not going to weld on 100% of the time on electropositive, but there is some perks on changing the polarity using or square wave AC and balancing from a limited time on the electronegative and then changing to electropositive, and those effects, as you can see here, they look really different. If we look in between the one that is completely on electronegative and the one that is completely on 50-50, I'm not showing you one case that it's fully electropositive, but as you can see here, we can see that increasing the time on the electropositive side increases what it's called the clean action. It helps you to remove all the oxides that are on the surface layer of the steel, so it widens the arc and also increases the cleaning action. As you can see here, the difference between not using at all electropositive and using 50 and 50, that's super interesting to see. But we have to be careful that when we go over electropositive, we are gonna be wearing off the electrode much more faster, right? I think I have it here. If not, I will share with you later how does like the tip looks like when you try to run a whole complete weld, or like this size of a weld with a whole time in electropositive. Your electrode ends up like round and not with a decent shape. All right. Any questions so far about this or other things that we mentioned before? All right. If we don't have any questions, we can jump to another fun demo that usually, again, when you guys come to the lab, we turn on the plasma cutter. That it's something that we haven't seen in the class, but you will see has a lot of similarities with the plasma transfer arc welding, and it's basically the plasma cutter torch. So this is the assembly. Again, we have a torch with an electrode, we have a retaining cap and a standoff spacer, and when you assemble all this together, it will look like this. I'll show you right now. And basically, this is the physics are super similar to the plasma transfer arc, but the plasma shed is strong enough to blow off all the material and get and be able to cut a few millimeters of steel plate if we need. So you can see that we can use the welding physics not only to weld, but also to cut and then weld again if you want, like we have here. But this is how we. These are the kinds of hands-ons that we usually do in the lab. Again, I'm sad we can't do it right now, but at least you get to see all the equipment that we have. The last thing I want to show you is the plasma transfer arc welding. As you can see here, this is the setup. We can identify the back cap. We can see that the electrode should be here inside the back cap, and we have the shielding cap that now, instead of having only one gas, we have three. We have the shielding gas, the plasma gas, and then we have the gas that contains all the powders if we are, for example, doing some hard facing or corrosion resistant surface alloys. In this case, we are doing a hard facing deposit on a steel plate, nothing fancy, but you will see once it starts, you will see how all the powders, you can even trace the powders in the video. You see how the arc is gonna start, and the torch is gonna oscillate and make all the welding, the hard facing on top. And the end result, of course, it's not a weld, but it's a hard facing alloy. See, as you can see there is a cavity in the middle that's parameters, things that are not optimized, but you can see how the torch oscillates and goes building up on top of the previous deposit. It goes depositing more and more. So of course you can do this type of processes with PTAW, but also you could do welding, of course, as you saw in Dr. Mendes' class last week. So that's everything I have for these two processes. I will welcome to try to answer any question you have, but if not, this is everything I have for this seminar. Thank you for listening, and I hope you enjoy. And again, this is much more fun when we can go to a lab and see it live. But thank you for staying with me. So, does anyone has any questions that I can answer, or I can try to answer?
Yeah, I have a question, Alejandro, regarding the metal plate that you were using the differing currents on. Aluminum typically is just used with, only uses AC current, right? You had a DC electrode negative bead, and if that was aluminum,
yeah, that looks bad. Yeah, that was just for the sake of, yeah, that's a good thing that you pointed out, that the beads that I show you, we did in the lab with the intention of showing you how does it look like with different polarities. But it's true that the first weld on the left side, that's, if I'm not wrong, Wesley, the one that is completely electronegative, that's something that you wouldn't do in a real life process, right? That's what you want to
say? No, I just wanted to clarify that was just for a comparison only.
Yes. Thank you for bringing that up. I hope I didn't cause any confusion, but yes, as Wesley said.
Okay, thanks.
No, thank you for the comment. That's really helpful. For the shielding gas, is a mix of gas of argon and helium, more stable than pure argon. That has to do with all the rest of the parameters. It's not that one gas is more stable than another one. The gases, they have different properties, and well, there you go. But the pure argon in this case is much more stable than the helium. But if I'm wrong, please, Dr. Mendes or someone who has a.
Yeah, so involving the stick out length for the tungsten, if you want, I can just give you a couple ideas as far as why you would change it. But if, for instance, you're in a really tight area and you need to extend the tungsten to reach, or to get proper fusion, you can do that. But you can't go too far, otherwise you lose the shielding gas. To bring the tungsten back into the cup is no big deal if you want to configure it for, say, walking the cup through a groove preparation or something, you know, pulling the tungsten back in. But yeah, there's a limit to how far you can bring the tungsten out beyond the cup, just to provide some clarification with that.
Yeah, this is Eddie here. Just gave the example there for boiler tubes. Like sometimes when you're welding in the tangent, like Wesley said, you'll just stick out your tungsten just to get access, but then you're also kind of playing with fire there because you won't have that adequate shielding there anymore. So often what people do is just they put something up against on the other side of the wall just to enclose like the gas to get that proper shielding.
That's awesome. Thank you, Eddie, and thank you, Wesley, again for sharing your knowledge with all the group. That's super valuable of you guys that the guys that know more about this can share with us. So thank you for all the comments.
No problem.
Do you have any other questions that I could? Well, I guess we don't have. Just if we have, again, you can always like send me an email with questions. If I can answer you right away, I will ask the right person to answer you. So please, you're more than welcome to ask me anything. It doesn't have to be right now, right here, but you have my contact information. You can send me an email whenever you want. If no one has any more questions, that's it from my side. I don't know if Dr. Mendez wants to say something or any other comment. I guess not. So thank you very much for staying with us, and I'll see you next week with it's gonna be the gas metal arc welding, sub-arc welding, and stick welding demos. It's all in one seminar. Oh yeah, and Eddie and Wesley, please. That's a good thing that you're here. Huh? Thank you very much.
Right, everybody, let's stop here, and I'll see you on Thursday to continue with sub-arc welding. Thank you, guys. We're learning so much. It's my fortune. You pay tuition and I learn. That's okay. So I'll see you on Thursday. Bye-bye.